Hello and welcome to the screencast on range. Now this has to do with domain. So domain was all possible input values of x for which the function is valid. Range is all possible output values, or the y, for which the function is valid. So again, looking at our parent function that is linear, f of x equals x, we see that there are no breaks, asymptotes, or holes going on in this line. So our y values all match up with some x value. Therefore, our range will be all real numbers. Now, the next one, we look at our y values on the parent function, f of x equals x squared. And we see that there's a point where we don't have any y values. Okay, and that's after y equals 3. So this is the point 0, 3. So we know that our range will be all real numbers such that, now you can either use f of x, the function of x, or y. So I'm going to use f of x here. So all real numbers such that f of x, and f of x needs to be greater than or equal to 3. Now again, as I said, you could say the range is all real numbers such that y is greater than or equal to 3. Either of those will work. Looking at our next one, again we have the parent function, f of x equals the square root of x. And we look at those y values again, -1, -2, -3, -4, -5. And we see that right here we have a value, but then the graph goes up. And we don't have any of these values down here. So we know that our range will be all real numbers such that f of x is greater than or equal to -4. Okay, that was a little squished. So our range, all real numbers such that, again, you could say y greater than or equal to -4. Because we have y is -1, -2, -3, -4. It has a value, but then it's going up. Our next parent function that we see is going to be f of x equals the cube root of x. And we see that all our y values do in fact have x values. It may take a long time for this y value to have an x value, but it will happen. So therefore, our range will be all real numbers. Looking at the parent function, f of x equals 1 over x squared. We see that these have asymptotes on the x and y axis, which means that these lines are approaching but never equal that value. So we have an asymptote here, and we have an asymptote here. So looking at our y values, we have positive values, but here we do not have a value, and we're missing all of these y values as well. So our range will be all real numbers such that f of x has to be greater than 0. It can't equal 0 because we're missing that value because there's an asymptote there. So it can't be equal to, so it just has to be greater than 0. Looking at the parent function, f of x equals absolute value of x. We look at our y values. We see that there are positive y values. There is a 0, but we are missing all of these negative values. So our range for this function will be all real numbers such that f of x is greater than or equal to 0. Because it can be equal to 0 at this point. We do have a value at that point. Looking at the parent function f of x equals 1 divided by x, we have these curves that again are approaching the asymptotes but never equal it. So we have asymptotes on the x-axis and on the y-axis. Now, looking at our y values, we have positive values, we have negative values, but we're missing that 0. So our range is going to be all real numbers such that f of x does not equal 0. We have the positive values, we have negative values, but we're missing that 0. Now it's your turn. So looking at these graphs, we have x is -1, x is -2, x is -3, x is -4, y is 1, y is 0, y is -1. This graph goes along here and has the parent function f of x equals 1 over x squared. Please find the range of that graph. We have this graph here that starts, we have -1, -2, -3, -4, -5, -6. And you want to find the range for this parent function, f of x equals the square root of x. Thank you for listening, and good luck.